our math. 158, homework discussion. Section 8.4. This is the last section that I should have done last Tuesday, but somehow because I didn't get the time change, I didn't get to this. Shame on you for not telling me about the correct time during class. Problem number 1 says the square root of 36 minus the square root of 100. Well, we know the square root of 36 is 6, and the square root of 100 is 10. 6 minus 10 is negative 4. Straightforward problem. Problem number 9. It says 6 square roots of 18 minus the square root of 32, and then add 2 square roots of 50. Okay, so because the radicands are all different, we're going to have to do some simplifications. So let's think about 6 square roots of 18 first. This is 6 square roots of 18 is 2 by 3 by 3. Square root of 32 is the square root of 2 by 2 by 2 by 2 by 2. And the square root of 50 is 2 by 5 by 5. We're going to simplify each radical. Here we can take a 3 out. So that gives us 6 times 3 square roots of 2. Here we can take out a pair of 2's. This comes out front, 2 by 2, left with the poor little guy inside. And here we can take out a pair of 5's. So that's 2 times 5 square roots of 2. Okay. So at that stage, we'll go ahead and clean these up. Looks like we have 18 square roots of 2, take away 4 square roots of 2, add 10 square roots of 2. Okay, 18 take away 4 is 14, plus 10 more, it's 24 square roots of 2. There's our final answer. Simplify each of the terms before you add them up. Okay, number 17. It says 3 square root of 72m squared minus 5 times the square root of 32m squared, and then minus 3 square roots of 18m squared. Read the directions up at the top. It says assume all variables are positive real numbers. M is bigger than 0, which means if we ever run into the square root of m squared, we can just write m. We don't have to worry about the square root of m squared being the absolute value of m. Okay, so once again, we clean these up. If I don't know 72 right off the bat, 2 goes into 72 36 times, and that's 6 by 6. So I can write this as 3 times the square root of 2 times 6 m squared. 32, if I don't know that one, I can divide 2 in there and get 16, and then there's a pair of 4's. So 5 times the square root of 2 by 4 m squared. And 18, I know is 2 times 9, 3 by 3 m squared. Okay, so I've sort of cleaned up my radicands, finding pairs where I could. There's a pair, 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 there's a pair. Each one of those pairs comes out front. So I have 3 times 6 times m, square root of 2, 5 times 4 times m, square root of 2, 3 times 3 times m, square root of 2. Cleaning these up, 18m, square root of 2 minus 20m, square root of 2 minus 9m, square root of 2. Okay, so if I want, I can just go ahead and add these up. 18 of these things, take away 20 of them is minus 2m square root of 2 minus 9m square root of 2 minus 11m square root of 2. Okay, if you don't like that, what you could do is look at these three terms, see what they have in common. I can take out the m square root of 2. I'll take them out the back instead of the front. And then that leaves me 18 minus 20 minus 9. Just double checking. This times 18 gives me that. This times negative 20 gives me that. And this times negative 9 gives me that. So, sure enough, 18 take away 20 is negative 2, negative 11 m square root of 2. Okay. So not terribly bad if you simplify each term. That was problem 17. Look at 23. 23, we have 3 cube roots of x squared y. Notice there's no triples there, so I can't clean that up. Minus 5 cube roots of 8x squared y. 8x squared y. Okay. Let me write these to the 1/3 power. What I want to do is to try to somehow combine these radicals, if at all possible. So I have 3 times x squared y to the 1/3, take away 3 8x squared y to the 1/3, and then take away 2 8x squared y to the 1/3. So let me just double check and make sure this makes sense. Minus 3 minus 2, that's minus 5. Okay, so that makes sense. And let me see if I can clean these up at all. So this first one, there's not much I can do. 3x squared y to the 1/3. Okay, here I see the 8. Let me highlight this. 8 to the 1/3. I know that's the cube root of 8, which is 2. So I can write this as 3 times 2, and then I'll leave the x squared y to the 1/3. And then I'll do the same thing here. Again, I see an 8 to the 1/3. That's the cube root of 8, which is 2. So I have 2 times 2 times x squared y to the 1/3. Okay, we'll clean this up a little bit more. 3x squared y to the 1/3, take away 6x squared y to the 1/3, take away 4x squared y to the 1/3. Well, hopefully you can see I've got 3 take away 6 is negative 3, take away 4 more is negative 7x squared y to the 1/3. If I want to leave it that way, I can. It simply says to simplify, those are the directions. So if I wanted to write it back as a radical, I could do that. Cube root of x squared y. I would think either one of these would be acceptable. You might want to look in the back of the book and see which way your author leads it. Because the original problem was as a radical form, my guess is he's leaving it this way. Okay, interesting problem. Pretty high degree of difficulty there. Let's look at 27. 27, probably a little bit easier. There's no variables in this one. We have 5 4th roots of 32, and we have 3 4th roots of 162. Okay, so 32 I recognize as 2 to the 5th. 2 to the 5th, right? 2 by 2 by 2 by 2 by 2. So this will clean up as 5 times 2, 4th roots of 2. Again, what I did was I realized 32 was 2 by 2 by 2 by 2 by 2. There's a group of 4 that came out front. Okay, so that takes care of the first term. Now, I don't recognize 162. So let me go off to the side. 162. 2 goes into it, 81. 81 is 3 times 27, which is 3 times 9, which is 3 times 3. Okay, so I have a 2 by 3 by 3 by 3 by 3. And there's a group of 4. That's going to come out front. So this will be plus 3 times 3, 4th roots of 2. So now it goes pretty quickly. I've got 10 4th roots of 2 plus 9 4th roots of 2, 19 4th roots of 2. Done. Okay, look at that one a couple times. Number 33, I have an asterisk around this. I wonder why that might be. Who knows? 33 has the cube root of 64 xy squared, and then plus the cube root of 27 x to the 4th, y to the 5th. Okay, so 64. I should, after playing with these long enough, recognize 64 is 4 times 4 times 4. And then I have y, or x times y squared. No other x times y squared. No other quadruples there. Here is a triple. Sorry, we're looking for triples. So there's a triple. No other triples. And then I have 27, which is 3 by 3 by 3, and x to the 4th. So 4 factors of x. Obviously a triple there, and then I have 5 factors of y. I'm not going to write them out. So I have a triple. I have a triple. There's a triple in here, right? And so let's pull the triples out, and let's see what's left. We have 4 cube roots of xy squared plus 3xy cube roots of xy squared. So factor out the xy squared, or cube root of xy squared. And what's left is 4 plus 3xy. Okay. So, yeah, out of these two terms here, this is a term. Remember, terms are separated by plus and minus sign. They had a common factor of the cube root of xy squared. So both of them had that. So I factored that out. You can factor it out front if you like. I think it looks a little bit prettier if you factor it out the back. So there's my common factor coming out the back. And if you're unsure whether that's correct, you can multiply this back together again. There's 4 of them, and there's 3xy of them. Okay. Number 39. Directions say simplify. Number 39. I have the square root of 8. And I'm subtracting off the square root of 64, square root of 16. I can do this a couple of ways. The square root of 8 is 2 root 2. The square root of 64 is 8. And the square root of 16 is 4. So this is 2 root 2, take away 2. And that's about all I can do there. I suppose if I want to factor the 2 out, I could. I'm not sure this is simpler. Both of these, I would say, would be fine. Okay. Another approach to this, whenever you have 2 square roots, I could write this as the square root of 64 over 16. Right, 64 over 16, which is the square root of 4, which is 2. And that's the same as this. Okay. So, I'm not sure one is easier than the other. That was problem 39. Problem 45. 45, we have root 32 over 3, and these are square roots. And then plus 2 root 2 over 3. And we have minus root 2 over root 9, but immediately I know square root of 9 is 3. So these all do have a common denominator. Square root of 32 over 3, and 2 square roots of 2 over 3, and minus the square root of 2 over 3. So right off the bat, because they all have a common denominator, I can add them up. And I can write this as the square root of 32 plus 2 square root of 2 minus the square root of 2 all over 3. And just looking at these two guys, I've got two of them there, take one away. So I have the square root of 32 plus 1 square root of 1 square root of 2 over 3. And let's make sure I had 2 square roots of 2 here, and I'm taking away 1 square root of 2. I got two things, take away one thing, that leaves me one of those things. 2 apples, take away 1 apple is 1 apple, right? So that's the top. Now that's not the final answer because I can simplify the square root of 32. So again, 32, 2 times 4 times 4. So I have the square root plus the square root all over 3, 5 square roots of 2 over 3. Okay. So you might want to try that a couple of different ways. There's the solution. Problem 51. 51, we have 3. Now this is the cube root of m to the 5th over 27. And then minus 2m, the cube root of m squared over 64. And I'm going to write it this way. Cube root of m to the 5th over the cube root of 27, just breaking this cube root of fraction into a fraction of cube roots. And do the same thing here, cube root of m squared over the cube root of 64. The reason I'm doing that is because I should know what the cube root of 27 is. I should also know the cube root of 64. So cleaning both of those up, I've got 3. Now notice I have 5 factors there. Let me take a triple out, leaving the cube root of m squared. This is 3. And there's not much I can do here. I just have the cube root of m squared. And this is 4. So we're getting a little bit closer to the end. Here the 3's cancel. So I have m cube roots of m squared minus 2. Let's cancel here. So that gives me minus the cube root of m squared over 2. In order to subtract or add fractions, I got to have a common denominator. So I'll do a 2 over 2. That gives me 2m cube roots of m squared over 2. Take away the cube root of m squared over 2. So that gives me, I got 2m of them. Take away, let's see, let me just put these all over 2 for starters. 2m cube roots of m squared minus the cube root of m squared. About the only thing I can do, just looking at the numerator there, I can go ahead and factor out the cube root of m squared out of the back. I'm not sure I have to do this, but yeah, look at the answer in the back and see what he has. You know, here, if I'm just checking, there's 2m of them, and there's minus 1 of them. So 2m of them, minus 1 of them. Here's my final answer. Or if you want, you could leave it this way. Both are correct. Okay. The last problem in the set is 53. So number 53, we've got 3 times the cube root of 2 over x to the 6th. I'm going to break that up immediately. Minus 4 times the cube root of 5 over x to the 9th. And again, I'll break that one up. So 3 cube roots of 2 over the cube root of x to the 6th minus 4 cube roots of 5 over the cube root of x to the 9th. Okay. So on the bottom of this first one, I've got 6 factors of x. That's 2 triples. So I've got an x squared. And here I've got 9 factors of x, so that's 3 triples. So that would be x cubed. To get a common denominator, I would have to do an x and an x, right? So now I can subtract. I've got 3x cubed roots of 2 over x cubed. Take away 4 cube roots of 5 over x cubed. There's not much I can do. The common denominator is x cubed, and I have 3x cube roots of 2. Take away 4 cube roots of 5, and that's about as best as you can do. Okay. I suppose it wouldn't be bad to leave it this way. That's certainly acceptable as well. Again, check the answer in the back of the book, see what the author has. Okay, so we've been plugging away here 20 minutes. Again, practice the problems, check the answers in the back, ball up your work, practice the problems, check the answers in the back, check the video, practice the problems. Practice makes perfect. You should be able to do these consistently well. Just work the same problems again and again and again. We're going to have a test next week, right? So tomorrow's the 10th. So figure the 17th is the test on this material. You really want to get it down pretty well. Okay, let me go ahead and stop this, and I'll shoot this out to you, and hopefully I'll see you all tomorrow night.